Good morning, everybody. It's a pleasure to be here in front of you in Warsaw today. And I'm thankful for the organizers for the invitation and organizing such a wonderful event. And I'm happy to see a full audience here that there's so much interest in the subject of BIM. My subject today, BIM is magical. Is this thing possible? How is it possible? So, for sure, I won't be telling you stories of disappearing rabbits or disappearing stuff or pulling rabbits out of a hat, but I will guide you through a story of how we, as a company, as architects, managed to develop a BIM project successfully. So I will be showing you not just only models and 3D models, but also I will dive into the meaning of processes and how they helped us develop this project. But before I begin, who am I? My name is Agron Deralla. I'm a graduate engineer of architecture. Until year 2016, I have been working as a project leader in architecture. And from 2016, I took the opportunity, and since then I'm working as a BIM manager or a coordinator for the company AllesWirdGut in Vienna. So my main tasks in the office are mainly BIM coordination and collaboration with our external consultants, but also internal processes of management, internal structures, and process definition in the office. In addition, I'm also a member of the Building Smart Austrian chapter for the software implementation. And since you can see, during the day I talk a lot about BIM, so in the neighborhood, in the office, I'm also known as the Dempster. Who is AllesWirdGut? We are an architectural company. We are like around 70 friends working closely together in Vienna, our main office, but we also have a smaller office in Munich. And we design and develop all sorts of projects, like the Doppelmayr headquarters in Hohe Brücke in Austria, which is Doppelmayr is one of the biggest cable lift producers in the entire world. So whenever you're skiing somewhere, probably you're going to be taking a Doppelmayr ski lift. Or the Funke Media office in Essen, one of the biggest publishing magazines, like the Westallgemeine Zeitung. But we also develop housing apartments for 300, 400, 500 units, or institutional buildings, schools, industry, actually everything that is interesting in the market. Not all of these projects are BIM projects, and this is the reason why. In Austria, the government invests quite a lot of money in the building sector, including the infrastructure, from which almost 40% belongs to the public sector. Alone in the city of Vienna, there's a project going on for the next 6 years to develop 430 or to approve 430 projects, enabling the creation of around 21,000 living units. These are all big numbers, but the market in Austria is currently maybe not so well developed like in other countries, European. Therefore, BIM accounts for only around 20% of all these projects. So now, we as planners, we ask ourselves, well, if we don't get contracted in BIM, should we do it in BIM? And the answer is yes. So there are some first steps that you should consider developing this project in BIM. So if, for example, you're being contracted in BIM and by an investor, it is very crucial that the investor takes the initiation phase. BIM begins there. And in the initiation phase, he decides why does he need this project in BIM, what are his goals, and also important is that the whole team, including the end user and the facility management, sits already on the table from the first day, defining the structure and how this structure is going to be used then during the exploitation of the building. Based on these facts, the EIR is being created, which is or the Exchange Information Requirements, which is a contractual document for the planning team. From there on, we go on to the BIM execution planning, which is also a crucial document for the development of a BIM project. And this is a document created by the BIM manager, like in this case it was mine, for the project. And there I define the rules, the roles, responsibilities, collaboration, communication, actually everything that is necessary to develop the BIM project accordingly. So, and this document must be applied by all planning teams. And if we don't get contracted in BIM, still BEP is a very important document to develop a BIM project. Then we test our software, because we're working in Open BIM, we're working in ArchiCAD, the other work in their specialized software because they are good at it. That's why we use IFC and Open BIM. So we tested if the IFC structure is being communicated properly, if the data, the metadata is being transported, and that's when we are sure, then we can continue with the project. The next step, coordination and process mapping. We need to define also how we're going to develop this project. So we need to define the processes and which processes are going to be then executed during this development of the project. And the fourth step, quality control and collision detection. These are new terms actually in the building industry that have more meaning now. And because when you deliver IFC models, you need to deliver them in high quality, and everything has to stick to its place. And in the fifth step, maybe this sounds absurd, but we should work as a team. I know it from my previous years that companies or consultants were working against each other, and this was really, really bad for the constellation and for the project itself. That's why it is important we are a team, and beginning from the investor, planning, construction, up to the end user. So we're working closely together. So if you learn all of these steps, then you can perform a beautiful BIM dance. Yes, this is a beautiful analogy that we have in our office, that BIM can be beautiful as a dance. But what does BIM have to do with dancing? In a dance, you are two people. So that means you're a team. And each one of you knows exactly at what time which step should be performed. Otherwise, it might hurt the other person, or it might not look beautiful. And another thing is that one of the persons is a little bit of more of a guiding figure, guiding the dance. So you see all these analogies can be found in our daily processes with the BIM. So if you learn actually these steps, then also the BIM project can be accordingly developed. So today's example, I'm going to present you on our project called Electronic Base System Center, which is or has been contracted by Bundesimmobiliengesellschaft. It is a state-owned company developing and maintaining buildings in Austria. And in this case, the user was the Technical University of Graz. It is a relatively small building with roughly 5,500 square meters gross area with 7 stories. But from inside, it is a bit more complex because we're dealing with an institutional building dedicated to microchips and microelectronics. So there are a lot of laboratories and experimental rooms. So the mechanical part was really crucial here to stick to the building and to the concept. This is not a project being contracted in BIM, but nonetheless, our BIM team has decided to develop it in BIM. So we have the architectural team, the electrical, structural, and mechanical engineer developing this project. So BIM, if you Google BIM, you'll see probably a lot of 3D models, collisions, and beautiful colors. But in my opinion, BIM is not only 3D models. It has to do a lot with processes. So if you define the processes of how you're going to develop this BIM project, you're going to be more effective. Therefore, who, when, and how this stuff is going to be developed. So imagine a project is like a cloud. In the beginning, you have a relatively small cloud with a little bit of tasks. The more you go deeper into the project, of course, the cloud is going to get bigger, meaning that you have more tasks which are also more complex. Therefore, it is necessary to find actually the best way to develop these processes, which can actually be the whole project, a part of a phase, or actually a small process that is going to be repeating itself inside the project multiple times. And in this case, we use already familiar or already existing norms in the market, the ISO norms like the 9650 Part 1, or our local norm in Austria, the 6241 Part 2, enabling the development of projects in BIM Level 2. So talking about norms, there is one organization responsible or dedicated to developing these norms, which is the Building Smart International. And Building Smart has its own local chapters in each country, which I mentioned also before. I'm a member of the Austrian chapter. But also it is interesting that Poland is one of the newest members in Building Smart. So actually everybody here in this room can join the Building Smart industry and dedicate their work to developing all these standards in order to have better processes. So when we have these processes, then we define activities for each discipline, who is going to do what at what time, which data format is going to be delivered, who collaborates when, what if something goes wrong, how does the process then has to repeat itself. So these BPMNs or business process model notations help the whole team to develop the project accordingly if it is a small process actually or a big process. So we have a lot of these BPMNs such as the information exchange and the quality control, or we have also more complex BPMNs like for the design control and the formwork planning. These activities are then documented in a digital way for our process management, which is in a Kanban. And each activity gets a card. So you're going to shift the card from process to process until it lands in the basket, until it's done. So actually, this raises the transparency throughout the team because everybody knows exactly at which moment, what is the status of the project, how it is developing, who is responsible, and how should it go further on. So these were the processes, and now we're going to dive into the modeling. So modeling is important in BIM, therefore the architects deliver their first models, in which case they do walls, doors, slabs, stairs, actually everything that is necessary for delivering a reference model or also scheduling. In the next case, we have our structural engineer who models then his load-bearing components. Then the electrical engineer delivering cable carriers, servers, emergency lighting, everything that is necessary from his side. And in the end, we have our structural engineer who delivers the air ducts, the water and sewage system, heating and cooling, up to some devices like fan coils or some funny shape-looking devices for suction of in the experimental rooms. So in this case, everybody, as I mentioned, is working in their own preferred software, and we're delivering IFC data. So this data is not only 3D geometries, but we're also delivering metadata. That means that all these 3D geometries have information inside them, whether this door is, or what is the fire classification of this door, or is this wall load-bearing or not, or this floor is flammable or not. So all this information can be exchanged throughout the whole team. On the other hand, if we notice something is wrong with a project and we need to talk about it and communicate, then we use the BCF or BIM collaboration format. And in my opinion, this is the case where the digital twin actually starts its first steps, because this is the creation of the structure that is going to be used, or actually, hopefully someday is going to be used in the exploitation phase of this asset. Since we are living still in a country or in Austria, not all companies are, let's say, BIM ready. Therefore, it is necessary to deliver also 2D documentation. Therefore, the BIM model serves as a source of delivering these documentation. So there are floor plans, sections, elevations, scheduling, and also partially 2D documentation. But it is important that we don't have a parallel world of the 3D and the 2D working together, but it has everything to come from one single source. Model position. I get this quite a lot of times from other BIM managers or other architects that Open BIM does not work because the model don't sit in the correct position. Well, that might be true, but the answer to this is failed coordination in the beginning of the process. If you coordinate your models in the beginning, then they will sit accordingly, because also the IFC structure is so structured that you can validate the position of the models based on their IFC local placement. Another mystery is the level of geometry. I know some, or I'm familiar with some consultants that are keen in modeling very complex devices, like in this case, this fire detector that has more 100 or hundreds of polygons. Well, in this case, as a BIM manager, I say, no, sorry, you cannot deliver this thing, so I have to reject this model and say, please deliver a more simplified version of this component. In my opinion, it is important that the component has its approximation of the volume for positioning, for collision detection and scheduling. But more important is that this component has its metadata embedded inside. So like in this case, we have the property set for electrical devices, like a power factor, IP code, rated current or voltage, which can be also communicated throughout the whole team. So these attributes, they are already embedded in the components and they can be validated and visualized, as we did for the fire rating system approval of if all fire safety doors are sitting in fire safety walls, because the other way around, fire safety doors in non-fire safety walls doesn't make any sense. Or we also controlled and validated if our components are load-bearing, because we needed exchange with our structural engineer. So every load-bearing component had to have its appropriate attribute. And another factor is the furnishing, which in this case, the end user or the technical university was going or is going to move in with a partial existing furnishing. So the other half had to be ordered. And in this case, the relation between the space and the furnishing helped us allocate where is this furnishing, new or old, going to be placed. So you see that the quality of these models is very crucial, and that's why you need also quality control. And if you do quality control of your models, then for sure I can guarantee you they're going to sleep better at night. We did all quality controls in Solibri Model Checker, where we federated all 4 models. And we did a lot of automatic validation, like the model position, geometry, tolerances, collision attributes. And also an important factor is we tested the buildability. Already in the planning phase, we tested, is this building buildable? Parts of the building or the whole structure itself. Since you can see, the wish from the architecture team was to leave the mechanical part visible. Therefore, manual validation was also important from the architectural team to walk inside this virtual building and control and check if all the components are sitting accordingly as they wished. Another aspect is the optimization, where the mechanical engineer succeeded here a very optimal room for the central heating, where he did this in collaboration with a structural engineer, an architect, and partially also building physicist concerning the acoustics. But believe me, this might look like there are a lot of pipes here, but believe me, there is space for the maintenance to walk between the pipes and to do the maintenance of all the necessary components. So our communication then took another dimension, of course. We were talking about specific places, all the collisions and this buildability, which all these issues then were documented in BIM Collab, where BIM Collab allowed us the centralized data bank of issue management, and everybody in the team had access to this database. So the transparency in the communication was really big, because everybody knew exactly at which moment which issues were open, which needed discussion, which needed approval, and also BIM Collab allows, based on these diagrams, to see how is the workflow of issue management going on. And another example or success story of our project is the communication and collaboration concerning the formwork planning and rebar planning, which we all did in IFC. And thankfully, to our BPMN process definition, it was clear for the whole team how this process is going to take place, because you need this process for each story. So the mechanical and electrical engineer were delivering their data. Then it was clear based on the BPMN who is going to take the approval and when is the architect going to open the voids inside his own model. Therefore, our meetings then took another dimension, because we were not talking anymore on paper, but we were projecting our virtual building on the wall and walking inside this virtual building. And this raised efficiency, because on our meetings, we could really solve a lot of problems and concentrate on other aspects. Therefore, for this project that took a year and some months, we solved more than 600 issues, from which 30 were very critical and that could impact negatively the construction site or the construction of the building. And we also found out around more than 200 collisions. Well, these might not look as big numbers, but I can see, I have realized that this happened, that there was a good management inside the team, because we were working as a team, and the coordination of these issues was efficient, and the knowledge of our consultants was also not at the basic level, but they were already a little bit experienced, meaning that they were delivering IFC files which were more clean. And the construction site began October last year, and until that time, the whole team delivered all necessary documentation for the construction site, meaning construction documentation, detailed planning, formwork, and rebar planning, which usually, from my previous experience, all these documents are being delivered on the site moments before the concrete is being poured, which is actually quite late. So, why Open BIM? Why do we do this? We have noticed that we have a higher planning quality, because the teams can then concentrate on design, on management, and we did a lot of model visualizations. So we did not just do 3D renderings, but also animations which then presented to the investor. Information was instantly available, meaning that all this data that was transferred via IFC, it was clear for the whole team which are the components and which data are embedded in the components itself. Transparency was of course then higher, because these IFC exchange we're doing on weekly basis, minimum, meaning that all the changes that were happening in all the disciplines were documented and then transmitted to the other teams. Early error analysis. One thing that I forgot to mention is that the teams, everybody started delivering their models in the preliminary design phase. So the IFC exchange began then, so we could actually start doing quality control and collision detection. And with the end of the design phase, we had a collision-free model or federated model, meaning that each pipe, every component was sitting correctly in its place. Reduced information loss because of the IFC exchange and where those IFC were located. And most importantly, because everybody in the team was familiar with what are the processes and how this project should be developed, we had a lot of fun. So actually the story just goes on, because we will not end in developing like small project with 5,000, but we're doing it now in projects with 50 up to 70,000 square meters with different functions of hotels, apartments, shopping centers, everything that is actually interested. And actually this is actually my call or a call to everybody here in this room, that embrace the technology, test it, learn the steps of how to develop a project, and try to experience the magical moment. Dziękuję.